this workshop. I'll be talking about the Akala EVM class. After this workshop, I hope you can learn a bit more about how to deploy some dApps on Akala and how some difference between the Akala EVM and some other EVM implementations and some of the problems we're trying to solve with some of our unique design. The intro about myself, I'm Brian, CTO and co-founder of Akala, also a senior Polkadot ambassador, as well as a top contributors for both Substrate and Polkadot. Calling you from Auckland, New Zealand, so it's 12 midnight here, but late, but it's fine. Really excited to see about the hackathon and looking forward to see some of the results from you guys. Quick intro about Akala in case you are not familiar with us. So we are a DeFi parachain connecting to Polkadot, and we do have a sister network connecting to Kusama. So the focus is DeFi products that including a stablecoin, a liquid staking derivatives, as well as EVM, decentralized exchange. So those three core offerings connect to each other, offer a core set of DeFi primitives, allow developers to build additional products on top of those. So this is a high-level tech stack of how Akala is implemented. So as the lowest level, we have Polkadot, which is as the shared security, same as all the parachains. And then obviously we have a Substrate runtimes with all the functionality implemented within the runtime. We have a bunch of protocols, for example, the AUSD stablecoin, and a bunch of other pilots coming provided by Substrate itself, and additional protocol pilots. And we also have the EVM plus pilots that implements the EVM functionalities to allow developers to deploy and run Solidity codes alongside with all the other Substrate code. In future, we do plan to integrate with the Wasm pilots, the Wasm smart contracts pilots in the future once that is mature and production ready. So that means Akala will become a multi smart contracts platforms. And on top of the Wasms, and then developers will be able to build dApps based on various functionality offered by the runtime. So for example, you can obviously write your smart contracts with Solidities and deploy them as a dApp, or you can build it using pilots with Substrate, and then having deployed and building a dApps on that, or you can using both. For example, the Tapio protocol on Akala is using this approach. They have a stable assets pilots built within the Substrate runtime, as well as a bunch of smart contracts deployed in EVM Plus, and having both of them connect with each other to create this hybrid approach of the contract development. So yeah, those are just a bunch of the useful links for you guys want to learn more about Akala. Actually, I can share the slides in the chat so you guys can follow along and collecting the links. So Akala EVM Plus, we're trying to build a sustainable EVM platforms and to address a bunch of issues we have observed on Ethereum and basically the Stackwell EVM implementation. Again, a bunch of links, documentation, tutorials, you can take a look yourself. So Ethereum, while it's definitely the top smart contract platforms out there, and it's also one of the oldest one and inherent a lot of legacy issues since the beginning. And obviously Ethereum doesn't want to do a lot of breaking changes to break capabilities that also greatly limit what they can do to avoid those problems. So one of the problem is a state explosions. That is a lot of developers, core Ethereum developers, spend a lot of time trying to write proposals, trying to find a solution on there. We still don't yet see how that will be solved. There are multiple possibilities, but none of them are confirmed, and no one have any ideas when they will be addressed. So state explosion is basically means deploy smart contracts cost a gas fee, but there is a one-time fee, and the contracts basically live there forever. And that is pretty much no incentives for people to delete all this unused storage in case the contract got abandoned. Previously, the destroyed contracts will refund you some of the gas, but that end up being abused, so that you don't even get the refund for the gas anymore. And that just means the number of contracts on Ethereum will only increase. Well, it's possible to destroy contract if you do that, but people don't usually do that. And that just means the storage cost of is not really reflect the actual cost of the storage. Like you spend when the gas fee is low, you only spend a few dollars. You can write some bytes on Ethereum that stores there forever. By thousands of nodes running worldwide, that just doesn't sound the right cost. So those greatly limited the scaling of Ethereum and causing a lot of usability issues. For example, just because so many storage are storing Ethereum, making the DEX requirements running a full node to be relatively high, and basically make it more expensive. And the more expensive to run the nodes, the less people run. And GIF realized this is a problem back in 2016. He wrote a spec trying to fix it. And after many years, the issue get closed. No one bothering actually doing anything with it. I don't know for sure, but I would imagine there will be one of the reasons out of many others that GIF decide to create Polkadot using all the lessons he learned when building Ethereum, trying to make sure all these known issues are properly addressed with a new design of the Polkadot. So with a similar mindset, Akala EVM Plus, we don't intend to build another Ethereum. There are a bunch of EVM-compatible networks and pretty much Ethereum clones out there. There isn't a lot of point just build another one. There are definitely a lot of upsides of EVMs and solidities. We have a very rich developer communities. We have very rich toolings. We have very rich documentations and tutorials and courses for education efforts. We would love to inherit all these good things, but at the same time avoid all those technical limitations driven by the legacy design. Be 100% compatible with Ethereum is obviously a very useful things to have, because the developer will just be very familiar with the new platforms and requires no changes and deploy the contracts and then it works. But at the same time, that means we have to inherit all the legacy decisions. It is impossible to fix Ethereum's problem without breaking capability. Otherwise, the problem will probably already be fixed. So this means we need to make the right trade-offs to judging between be Ethereum compatible at the same time, actually avoid all these known issues to make sure the network is sustainable. So we decide, because we're obviously Akala is a new EVM platforms. We don't need to inherit all the legacy things. We don't really need to be backward compatible. So we choose the future instead of the history. So Akala EVM Plus is built with Substrate, so it does not need to be limited with the limitations of Ethereum. We can customize pretty much everything. So that can enable a lot of interesting use cases that is simply not possible with purely EVM platform. For example, we can customize the transaction payment logics. On Ethereum, you have to pay ETH with gas fee. Every single transaction have to pay ETH with gas fee. There's just no other way. They are meta transaction systems, but in the end, it's just someone else paying the ETH as gas fee for you. But with Substrate, we can customize the transaction payment logics. So Akala accepts multiple tokens for the fee payments, including ERC20s. So because we do have a building Akala swap as part of the network, so we can leverage this for the fee payment handling. Anyone holding assets that can be directly or indirectly converted to the XA native tokens will be able to use them to pay for transaction fees. That just makes a lot of user experience much better than just a normal EVM platform. Similarly, we're using the same accounting models of Polkadot and Substrate. The Polkadot have a special concept for essential deposit. Every account on the Polkadot must have more than one dot. Otherwise, it will be considered as a dust account, and the balance will be wiped. So this prevents account having dust amount that is so little that cannot be used to do anything, including simply swipe the funds to another account. So that ensures the storage of the networks is sustainable. So, but obviously, this is just another incompatibilities with EVMs. On Akala, for example, any account must have 0.1 XAA token. So the transfer of less than the amount could fail if the destination account does not have any XAA tokens. So that's just another thing you need to be with deliberate breaking to ensure the storage of the network is reasonable. Another issue, the same issue of the state explosion is that writing storage doesn't really charge the right amount of fees, and removing storage doesn't refund your right amount of fees. So the solution we have is implemented using a storage meter. So basically, for every bytes you write, that will be including writing storages, make an empty storage to some positive values, or deploy a smart contracts. The contract code itself will be taking storages, will be charged for storage deposit. And then the storage deposit will be refunded if the smart contract is destroyed or the storage is clear. So the developers will have incentives, or the users will have incentives to free up the storage to get the deposit money back. And we also expose multiple rich feature APIs from Akala runtime to EVM precompiles, and that, for example, including the swap API offered by the Akala swap. And then the EVM path itself is also accessible by the runtime protocols. So for example, the Akala swap implemented using Palace will be able to access the ERC20 interface, and therefore supporting creating a trading pairs between native tokens and ERC20 tokens. Similarly, the XCM protocols on Akala implementation that allows transfer assets from Akala to other parachains natively supports both the native token of Akala as well as any ERC20s. So you can deploy ERC20 on Akala and using the XCM features on Akala to transfer the ERC20 token to another parachains. So just highlighting some of the features in the Akala EVM Plus. So firstly is merit tokens. On Ethereum, wrapped token or WE is super commonly used because to offer ERC20 representations of the ETH. And this kind of simplifies the smart contract development that you don't need to care about native tokens. You only need to deal with ERC20. But with the wrap tokens, you need to wrap and unwrap it to convert them between ETH and WETH. That is just another additional step. On Acala, we simply just offers ERC20 interface for all the native tokens as well as foreign tokens exposed to EVM as ERC20. So they are the same storage with two interfaces. One is the native substrate interface, one is the ERC20 interface. So if you transfer the native token, the ERC20 representation automatically updated and vice versa. So they just allow the smart contracts to pretty much no reason to support the native tokens handling, that they only need to deal with the ERC20 interface. So those are the ERC20 interface of all the bunch of the Acala native tokens as well as foreign tokens. So example, AUSD dot will be a foreign tokens, a bunch of Appchain tokens are also exposed. Those are special pre-deploy address, which is very easy to see. Those are the system address because a bunch of zeros. Then it's impossible to for someone else to create a similar looking address as a scam tokens, because you immediately know this is not SA tokens if it doesn't have that many zeros on the address. Another feature we have is Oracle Gateway. So in Acala, as to power the stablecoin protocols, obviously we need to feed the price information through the Oracle, and so we also expose this information to the EVMs using the precompilers. So you can use this Oracle APIs to access the token price information as well as the timestamp for the last feed. So in case if Oracle feeding is stopped or whatever reasons, you can use those to ensure to validate the data is recent. So again, this is a special precompiler address. So it's very easy to discover. So on Acala, obviously we support the traditional Ethereum RPC, but as a Polkadot or substrate projects, obviously we have to support the substrate RPC. We adopt both mechanisms to access the Akala EVM class. So the benefit is that all the Acala users, they are probably using a Polkadot wallets, and all the Polkadot wallets, they have to be using Polkadot wallets. Then for those people, we still want them to access the Akala EVM Pass without switching to Ethereum wallets, such as MetaMask. It doesn't make a lot of sense to require people using two wallets on a single blockchain. That just doesn't make sense. So we build the EVM pass in such a way that you can access it using the Polkadot wallets as well as Ethereum wallets. For the Ethereum developers and users, they are more familiar with Ethereum wallets such as MetaMask. So we also implement a bunch of the capability layers to allow developers, Ethereum developers using familiar APIs to access the Akala EVM Plus without actually needing to learn the Polkadot size. So highlighting some of the tools we've built, also could do a little demos of how to using them. So Chopsticks is a testing client for substrate chains that built by Acala team. So this allows developers to run a network, fork any network locally and for testing purpose. And Body.js is the capability layers between substrate and EVM. And the ETH adapter implements the ETH RPC, so the Acala substrate node doesn't need to implement that. So Chopsticks, if you have used Truffle or Ganesh, you'll be familiar with this, that you can easily create a fork of Ethereum mainnet locally and deploy smart contracts and do things to do some experiment before actually deploy the contract on mainnet to spend real money. So before Chopsticks, this was not possible on using any substrate chains. But Chopsticks implement this feature, so it is now possible to do that. You can, with a single command line, to create a fork of a network and run locally, and then you can just sign transaction, do whatever you like to test it. So do a quick demo for this. I hope you can see this. So this is running the Chopsticks. So this is using the Mandala config, which is basically defined using the Mandala PC. You can change this to any like Acala or other networks. It's forking this block number, override the storage. So in this case, assign Alice with the sudo permission and give it a bunch of tokens for testing purpose. So this is a remote config, but you can just copy paste the config locally and modify the config to point to your local config. And yeah, it will run, and then you have a network locally running. This will produce a block every time you're sending a transaction. So, so I just send some transaction. And yeah, let's produce a block. So this is, yeah, you can just do a bunch of testing. And because you have the sudo key set as Alice, then you can also perform runtime upgrades or do a bunch of additional configurations that you are not allowed to do on mainnet for other bunch of testing purpose. So Chopsticks also offer a bunch of development APIs as well. So for example, I can just run this div new block RPC, and you probably will notice they'll produce a new block as expected. And now the current block number is 457702, and I'll run the set head -1, and then you revert one block back. So this is super helpful for testing purpose. You can do something, try a complicated transaction, it failed, then you just revert last block, modify it, and do it again until you get working. Or you can use this to write unit tests. Or yeah, this is a bunch of other nice use case with this. I can see people have asked some of the questions, so let me quick check. So someone asked, a standard solidity contract on Akala EVM Pass safer than same contract deployed on Ethereum. It's not necessarily safer. It depends on how you view it. To the smart contracts developer and the use of smart contracts, it's the same. But to the networks of Akala itself, it is kind of safer because all the storage access of the smart contracts someone have to pay for it. So it just means people are not using your network for free. People are not, for example, using your networks to block storage to store a bunch of JPEGs. for one-time fees stored forever. So in that way, but it's not this. Can you give me the comparison from Asta and Moonbeam? Is this build DeFi? What does it actually means compared to Impala language? Would be amazing. So Asta and Moonbeam, now Moonbeam is 100% Ethereum compatible. So there's, as I previously mentioned, there's upside and downside. Upside is, well, obviously, if you're an Ethereum developer, you'll be super familiar with it. And the downside will be that it inherent all the problems of Ethereum. Moonbeam definitely trying a lot of things to doing improvements on top of that, but still, it will still be limited. And Asta will be a somewhat similar situations because it's also trying to do more or less the Ethereum compatible ways. What's the hardware requirement for forking right now? Like Chopsticks actually does not have much hardware requirements. It's just a Node.js server. It's doing a lazy loading, so it's only download the necessary storage when it's required. That again, it's upside downside. The downside is sometimes can be slow. If I need to browse some information, it can take a bit of time to load because it's doing lazy downloading but the upside is, well, if you never use read some storage, it will just never download that. And if you are not asking it to build a block, it does nothing, just sits there. So the hardware requirement is super low. You should be able to run this on pretty much any machine. Can I deploy a complete Solidity smart contract EVM Plus? Yes, you can deploy them. There are some capability considerations, as for example, I previously mentioned, there's a DApp account and the storage deposit, etc. So most of the contracts should just work without problems, but there are edge cases you need to be considered. But those edge cases are usually like really edge cases, not something you have to support. Like for example, transfer 1 unit of app tokens might not work. But normally it's completely acceptable to set a minimum threshold of transfer money. It doesn't make a lot of sense to allow users to transfer 1 unit of tokens. Someone is asking how much GB free space. I'm not sure what does that mean. So let me resume to the slides. So I showed you the Chopsticks. So that's for forking and testing. So that just means you can, yes, mentioned, makes the development on Akala much easier. You can not only fork the testnet, you can fork the mainnet, and make sure that will help you to make sure your mainnet deployment actually works before you spend the real tokens to it on the mainnet. And you can override storage to mix a bunch of the tokens on your local testnet, so you don't need to acquire, for example, a bunch of DOT to do the testing. Body.js. So Body is the capability layers we provide to unify the substrate as well as the EVM. So it offers multiple libraries and tools. The primary one is the Body.js. So it implements Ethers.js providers and was powered by the substrate RPC. So what does this mean? This means if you write your smart contracts using Ethers.js, if you write your dApps using Ethers.js, chances are you only need like 100 lines of changes to make it compatible with Akala. And then similarly, all the toolings like such as Waffle and those things can be that uses Ethers.js can also be compatible with Akala EVM Plus. There are a lot of tools are designed to work with Ethereum RPCs directly, for example, MetaMask. And we don't want to just not supporting those tools. So that's why we built this ETH RPC adapters that implements Ethereum JSON RPCs. Again, it's also just a Node.js server that you can just run locally. That will just implement Ethereum RPCs. So yeah, this just runs. This actually connecting to the Chopsticks nodes I'm running here. And this will just implement. This will just have a local instance. And then on the MetaMask, yeah, I'm already local, so connecting to local, so I can just start sending transitions. Actually, this was saying not connected, but it should work. Let's see if this actually works or not. But you can see this is talking with the MetaMask. I think because I was down a bit network switching, so it's probably confused a bit. Let me send another transition. Okay, it works now. So you can see there's a new transitions, new block is minted, triggered by this MetaMask transition. So you can see this is perform Ethereum core. Is specify storage limits, how much storage this transition can do. Transfer one ACA tokens to this Ethereum address. And yeah, I can just, yeah, so that's how the MetaMask interaction. So this one is fairly standard, so not super exciting. Then we have the Body examples repo highlighting some of the interactions with the using Body.js, using some of the unique features for Akala EVM Plus that are not accessible on other EVM platforms. So that's the things I would like to highlight. So the first example is the deploy contracts. They just show you how to use this to using Polkadot.js extension wallets to deploy smart contracts on Akala EVM Plus. So actually, so I want to connect to the local network. So it's connected. So it's connecting to the Polkadot.js extensions. I can pick one of the account. So picking the LS, the testing account, which have a bunch of tokens. I mint using by modifying the storage using Chopsticks and deploy a contract. And this is just making Polkadot.js transitions. And the contract's deployed, and you can see here we have EVM create transitions that create smart contracts with this address and use some gas and use some of the storage. So some amount of the tokens are reserved to compensate for the storage usage. And I can just call the contracts by signing another transaction. So that's just fairly simple examples. Quickly go through the code. So it's mostly it's relatively simple. So obviously this is using the Body libraries as well as the Polkadot extensions libraries to connect with the Polkadot.js extension. So this should also support other Polkadot wallets such as Talisman, sub-wallets, and others. So this is connecting to the node using the Polkadot.js, just providing the URL and connect to it. And then this is enable the extensions, connect to the extensions. And then using the signers that is created by the bodies, passing the corresponding informations, that including the WebSocket providers, the address, the signings coming from the extensions. And then the signer is implements the standard Ethers.js signer interface, and the rest of code is mostly the standard Ethers.js code. So if you are a Solidity developer, you should be very familiar. So that's just create contract factories, deploy the contracts, call the contracts. So those are just standard Ethers.js code. But underlying the hood is using the Polkadot.js extensions for the transition signings, as well as querying the on-chain state from the substrate node. The next example is the batch transition example. So this one instead is trying to do something a bit more interesting. So on Ethereum, there is a super common use case when you're interacting with pretty much all the DeFi protocol. Is the first thing is to approve a certain amount of tokens. The second thing is actually invoke the contracts to use the token. And you the best practice is always approve as much as you want to spend with those contracts. There are multiple instances causing by people approve too much. So this makes super annoying because every time you deal with the smart contracts, you need to make at least 2 transactions. And that will firstly takes time, secondly takes more transaction fees as well. So this can be solved with the batch transaction functionality offered by the Substrate. So this is a built-in Substrate pilots features, but it just works with all the different transaction types, including EVM transaction type. One thing to keep in mind is that using the Polkadot.js wallet means normally your transaction, your address is the Polkadot address format, which is like this one. But obviously on Ethereum, on the inside EVMs, you'll be dealing with the this Ethereum address format, which they are different. So our solution to this is we create this account binding mechanisms, allow you to either create a default EVM address that derived from the Polkadot address. So there's no private keys for such address. You can only access this address through the Polkadot.js extension. Or you can bind with MetaMask account by having the MetaMask account sign a message and send them to bind account. So in this case, we can bind the default address. And then this account is, those two are bind. So then any account I can, using MetaMask to send to this token some money. and this balance should updated. So it would end up being on this account. This could take some time, so I'm not waiting for it. Then in this demo, it will deploy the Uniswap and token contracts. So it's deploy 4 contracts in a single transaction. So yeah, so let's go back to the Block Explorer. So you can see this is a batch call. The call contains 1, 2, 3, 4 EVM transactions, and each of them will deploy a smart contracts. And you can see this will be 4 EVM transactions being created. So deploy the Uniswap contracts, the core contracts, the router address, and 2 ERC20 tokens. So this in total requires 13 tokens as both the transaction fees and the storage deposit. So, and then I can, in a single transaction, so this means user only need to sign 1 transaction instead of multiple to approve and add liquidities to the smart contracts. So in this case, it takes 2 tokens for both fees and the storage deposit. Normally, this is where the integration ends. But as previously already mentioned, especially on mainnet, you want to be a nice citizen. Clean up your garbage. Don't leave abandoned smart contracts on chain. So in this case, I can also destroy all these smart contracts, bring up all the spaces, and having all the funds refunded. Yep. So in this case, the contracts are destroyed. You refund 8 tokens. So mostly coming from the deposit to store the actual contract codes for those contracts. So this means, yeah, it's encouraged to recycle all these contracts. It's not only save your money, but also ensure the network is as efficient as possible. But of course, you don't have to do that if you just feel the money is not big enough. That it just means, well, you already paid for the storage fees with a reasonable cost. So that's okay if you just don't want to, you want to leave it alone. So you can see, so this one is also again a batch call using the special self-destruct method to destroy the contracts. So this leads to another features of Akala EVMs. We have this kind of beta testing features. So contracts, when you're deployed by default, the deployer is the contract's owner. Contract's owner have the abilities to destroy the contracts or upgrade the contracts. This makes development much easier. Otherwise, you normally need to have a lot more code to implement proxy patterns and bunch of additional things to having them. But obviously, having the owners always be able to modify the contracts or destroy that is not good. So during this mode, other users will not be able to call those contracts. So you cannot just deploy a contract and ask people to use it because they will not be able to use the contracts. Only you as the contract owners can do that. But once you are comfortable the contract is good, you can use the publish features to mark your contracts as ready to be used. and that will essentially revoke your owner permission and then allow other users to interact with your contracts. So you can no longer destroy them nor upgrade them. So this means you are able to deploy contracts, do a bunch of testing however you like. If they are good, publish them. If they are not good, you can just destroy them. Yeah, so, but showing the code a bit. So all the setup code is pretty much the same, so I'm not talking about them, but see highlighting the batch transition. So probably find the previous one. So in this case, it's doing a batch transition to deploy 4 contracts at the same time. This one is the code to create the transition. So in this case, using the contract factory, get the deploy transition data. And then instead of using the EVM-JS to deploy the contracts, won't be batched. This is using the substrate RPC, Polkadot.js RPCs to deploy, to create a transition or create an extrinsic. So similarly, this is also using, so this is making the calls to the pallets calls directly instead of using the EVM calls. And then with all the extrinsics, then we're using the substrate built-in features and the batch wall to bundle them into transitions and then sign and send. This is again using the Polkadot.js native API to send the transitions. Yeah, then the rest is just handling the code. So similarly for others, getting the extrinsics, putting them into a batch, and send the transition. So those codes will be a bit different than the EVM-JS code, but it is the standard Polkadot.js code, which is also not complicated. So if you already have experience using Substrate, you should also be familiar with those methods. Let me check if questions. Yeah, so someone I already answered the name of Akala for the Mandala extension. Kura is the Kura network. Can you use Hardhead with Body.js as you can with Ethers? Yes. In fact, we do have. Let me find it. Yeah, we have Hardhead tutorials, truffle tutorials. So just follow them. It should teach you how to using Hardhead with Akala. What's further addressed this is Uniswap concept. Pretty much special contracts to handling the interactions with the core contracts, because for Uniswap B2, the core contracts only offers very, very low level primitives, which is very hard to use. So people usually using the router contracts to deal with Uniswap. Is the destroy the same code as self-destruct? So it does the same thing as self-destruct. Yeah. Does Body.js work with other EVM pallets integrate substrate chain as well? Not exactly. Other substrate chains, other substrate EVM chains, they are using Frontier. which is very similar to the Akala EVM. Well, the Akala EVM Palace is a fork of the Frontier EVM Palace, but with additional modifications to suit our needs. For example, the account binding. So Body.js cannot directly used with other EVM chains, but despite having that said, it is definitely possible to. There's no reason why the Body.js cannot be adapted to support other EVM chains. Because on the end, it's just translating Ethereum transactions and Ethereum RPCs into substrate transactions RPCs. So that is definitely possible, but requires additional work to support that. So yeah, that concludes the workshop today. So hope you guys learned something from it. And yeah, feel free to pop more questions. Is EVM benchmark to be performant? We haven't done a lot of benchmarking, but the performance comes from multiple aspects. One is the on-chain performance. In that way, all of the EVM chains is using the same EVM execution engines. So we all will have pretty much the same performance. Akala does have slightly more overhead because we support the storage meters. So we will do additional work to handling the storage. But this shouldn't be a large overhead. So it should be largely the same. And then there's another performance from the RPC point of view. We're using a very different approach that instead of having the RPC substrate nodes implementing the Ethereum RPCs, we have separate Node.js servers, each RPC adapter implementing them. So that performance will not be tied to the node performance. And that also means the setup can be easily auto-scaled, just like any other Node.js server. We can just auto-scale the Node.js servers without spin up more substrate nodes, which can be costly and expensive to scale. Is building a DApp on EVM Plus, does end user need to know you are interacting with Web3 or that can be handled entirely on the backend? So it depending how you do it. If you want to do it truly permissionless way, non-custodial, the user will need to have a wallet. Of course, the wallet will store the private keys, and all the on-chain iterations will be signed by the private key approved by the user. So in that way, it's impossible to hide. If you're taking alternative approach, you custodial the keys, private keys for the users, which will make your servers centralized. But if you are offering a centralized servers to access dApps, then yes, you can completely hide the interactions from users because it's your server signing the keys, but you pretty much have very, very different trade-offs compared to normal dApps. What type of projects does Akala team expect from us, DeFi, NFT, GameFi, what? So we are mostly focused on DeFi, but NFT and GameFi is still something relevant for us as well. Because they all, in the end, are solving problems. And what we are mostly looking for is unique and interesting ways to solve problems. We present the EVM Plus with a bit more additional features compared to normal EVM platforms. And we are looking for solutions that can leverage all these new features to solve problems. And it would be great if there's some DeFi solutions that build on top of AUSD, the stablecoin, for example. But if you can find it those technology can be used to solve some other problems. I don't know, global warming or something. That will also be great. It just means our technical tech solutions is useful. How much max TPS are Acala observed? Like TPS again is another subject of thing each. Depending how you measure it. Most people measure transfers. We observe on mainnet that one block can contain about 2,000 each transactions. With a 12-second block time, you can calculate TPS. But the TPS on the Polkadot ecosystem is not really a thing to compare, because the performance is largely limited by the Polkadot, and because the architecture's point of view ensure security, the TPS for all the projects will be on a very, very similar scale. Is there any DApp already using Body.js to fill the user experience? Most of the dApps on Akala right now, or Kura right now, is using the more traditional Ethereum stack, not leveraging some of the features such as batch transaction. So unfortunately, I don't have good examples for you. But again, that is one of the reasons why I'm doing this workshop, to hopefully see developers can leverage those features to build some interesting applications.